In this 8th topic, we are solving trigonometric equations. Now, the difference between solving an equation and proving an identity. An equation like this is going to be true for some values of theta. With an identity, your equation works for every single possible value of theta. All right, now let's have a look first of all at this very simple equation: sine theta is equal to a half. Now, you are familiar with the concept of arc sine. Arc sine of a half is going to equal 30 degrees, and that's what you did in grade 10. However, you know that sine is positive in two quadrants. It's positive in the first and in the second quadrant. And so the arc sine of a half is only going to give you that angle over there. However, we know that sine of 180 minus theta is the same as sine theta. So our solutions, if we want every single possible solution, we are certainly going to get the 30 degrees. We are going to get 30 degrees plus any multiple of 360, like we saw when we dealt with negative angles and angles bigger than 360 degrees. But we can also have that our angle theta is going to be 180 degrees minus 30 plus k 360. 150 plus k 360, where k is an element of the set of integers. So we are saying if you put 30 degrees into your calculator and you type sine of 30, you're going to get a half. If you put 390 degrees and you type sine of 390, you're also going to get a half. If you take sine of 30 minus 360, sine of minus 330, you are going to get a half. Sine of 150 is going to be a half, and so on. So this equation, sine theta equals a half, arc sine of a half is 30, but the solution to that equation is an infinite number of possibilities. 30 plus any integer multiple of 360, or 150 plus any integer multiple of 360. In the same way, if we take cos theta is equal to half, now you are familiar with the concept that arc cos of a half is going to be 60 degrees. In which two quadrants is cos positive? Well, cos is positive in the first quadrant and in the fourth quadrant. So if we want every single possible solution to that equation over there, we could say 60 degrees plus any integer multiple of 360, or, so in other words, that angle there is 60. We could take 360 minus 60, but it's actually much quicker just to talk about minus 60 like that. So when we solve a cos trig equation, we're going to write plus or minus 60 plus k 360. If we get the equation tan theta equals a half, well, arc tan of a half is going to be, let me write this down, arc tan of a half is going to be 26, let's round it off to one decimal place, comma 6 degrees. Now tan is positive in that quadrant and that quadrant over there. So when I solve this equation, I can write that theta is equal to 26, 6 plus again any multiple of 360 degrees. But if you look at these answers, it's actually easier to say 26, 6 plus 180 gets me there, plus another 180 would get me there, plus another 180. And so for tan, when we solve that tan trig equation, we are going to say it's 26, 6 plus any integer multiple of 180 degrees. And for each one of these sums, we need to write that our k value is an element of the set of integers. All right, so when we get an equation like that, okay, we have 4 sine theta plus 1 is equal to minus 1. The first thing you're going to have to do is to isolate the trig ratio. So we're going to write this equation as 4 sine theta is equal to minus 2. So sine theta minus 2 over 4 is going to be minus a half. So when we work out arc sine of minus a half, we're going to get negative 30 degrees. So our solution to this equation is going to be minus 30 plus k 360, or our theta value is going to be 180 degrees minus 30 plus k 360. Okay, that's going to be 210 plus k 360, where k is an element of the set of integers. Again, just think about it. Sine equals a negative number. In which two quadrants would sine be negative? In the second quadrant, 210, and the fourth quadrant, minus 30. Right, let's have a look at this example over here. We have that 4 cos theta is going to equal minus 5 minus 1, which is minus 6. So cos theta is going to be minus 6 over 4. Okay, in other words, minus 3 over 2. Now, when you try and take arc cos of a number that is not within the interval from minus 1 to 1, you're going to get math error. And that is because the maximum value that cos can have is 1, and the minimum value it can have is minus 1. So if you get an equation like this, cos theta equals minus 3 over 2, arc cos of minus 3 over 2 does not exist. Okay, so that equation has no solution. This example over here, we would have 3 tan theta is equal to minus 1. So tan theta equals minus 1 over 3. If you take arc tan of minus 1 divided by 3, your answer becomes minus 18, 4 plus k 180, where k is an element of the set of integers. Okay, so now we're going to make it one step more difficult. Now, you still need to get your ratio on its own, but of course the angle we're dealing with in this sum looks a little bit messier. So you peel away all the extra things that are added onto the tan. How do I get rid of an add 3? I minus 3. So I get that 3 times tan of the angle is equal to minus 3. That means that tan of 2 theta plus 10 is equal to minus 1. How do I get rid of a tan? I arc tan. So arc tan of minus 1 becomes minus 45 degrees. So I have 2 theta plus 10, the angle. Arc tan of minus 1 is minus 45 plus k 180. I haven't finished until I have the theta by itself. So in order to get rid of the add 10, I am going to minus 10. So 2 theta is going to be minus 55 plus k 180. And to get rid of the multiply by 2, I'm going to divide both sides of that equation by 2. And so I land up with theta being equal to minus 27,5 plus k 90. Again, where k is an element of the set of integers. The last example, 3 cos of 3 theta minus 20 plus 1 is equal to 0. When I rewrite that equation, I'm going to get that cos of 3 theta minus 20 is going to equal minus 1 over 3. Okay, so we arc cos of minus 1 divided by 3, and our answer becomes 109,5. So 3 theta minus 20 is equal to 109,5. That would be your arc cos plus k 360, or 3 theta minus 20 would equal minus 109,5 plus k 360. It is much better to write it down as two separate equations, because when I solve for theta, I cannot do it with a plus minus in front of that 109,5. Right, so if I have 109,5, I want to add 20 to both sides. And then I want to divide by 3. And so my theta value is going to be 43,15, so I'm going to round it up, plus 360 divided by 3, k 120. In this case over here, I have minus 109,5, and I'm going to add 20 degrees. That gives me minus 89,5, and divide it by 3, and my theta value becomes minus 29,8 plus k, again 120, where k is an element of the set of integers.